আসসালামু আলাইকুম রহমতুল্লাহি ওয়া বারাকাতুহু। আমার প্রিয় শিক্ষার্থীরা, তোমরা যারা ইংলিশ ভার্সনের এই মুহূর্তে এই টিউটোরিয়ালটা দেখা স্টার্ট করেছো, তোমরা মাস্ট এটা জানো যে ফিজিক্সের বেসিক শুরু হয় যে অধ্যায়টা থেকে, যে ফিজিক্যাল কোয়ান্টিটিজ অ্যান্ড মেজারমেন্ট প্রথম অধ্যায়টার পরে। এটা এমন এক চ্যাপ্টার বা এটা এমন একটা নলেজের স্টার্টিং যেটার উপরে ফিজিক্সটাকে ভর করে আমাদের সামনে যেতে হবে, এবং এই অধ্যায়টার গুরুত্ব সবসময়ই বেশি। তোমরা দেখো যে আমাদের এই কন্টেন্টগুলোকে চিন্তা করে দিস লুকস টু ইজি, বাট এটার আন্ডারস্ট্যান্ডিং লেভেল, এটার ইমপ্লিমেন্টেশন এবং এখানে যেই জিনিসগুলোকে পড়তে হয় এগুলোকে মন থেকে বুঝতে পারলে আমার মনে হয় পরবর্তীতে ফিজিক্স পড়াটা অনেক বেশি ইজি হয়। সো আমি এই ভিডিওটাতে চেষ্টা করব পুরো অধ্যায়টাকে ইংলিশ ভার্সনের বইটাতে যা কিছু এক্সপ্লেন করা হয়েছে সেটাকে আমার মতন করে ব্যাখ্যা করার, এবং তোমরাও ট্রাই করবা যখন এই চ্যাপ্টারটা রিডিং পড়বা তখন যাতে ক্লিয়ারলি প্রত্যেকটা কনসেপ্ট তুমি বুঝতে পারো। সো ফার্স্ট অফ অল আমাদের রেস্ট অ্যান্ড মোশন বুঝতে হয়, আমাদের টাইপস অফ মোশন বুঝতে হয়, মোস্ট ইম্পর্টেন্টলি স্কেলার অ্যান্ড ভেক্টর কোয়ান্টিটিজ আছে যেগুলো I think তোমরা অলরেডি এগুলো জেনেছো। ডিস্টেন্স অ্যান্ড ডিসপ্লেসমেন্ট হুইচ ইজ মোর অর লেস স্কেলার অ্যান্ড ভেক্টর, স্পিড অ্যান্ড ভেলোসিটি, অ্যাসিলারেশন অ্যান্ড রিটার্ডেশন অর ডিসিলারেশন। তাহলে এই যে এই তিনটা কোয়ান্টিটিজের ক্ষেত্রে আমরা যখন তিনটার ক্ষেত্রে স্কেলার অ্যান্ড ভেক্টর পাই, এই কনসেপ্টটার উপরে বেস করে কিন্তু এই চ্যাপ্টারটাকে আমাদের বুঝতে হবে। ইকুয়েশন অফ মোশন ইজ দ্য বিউটিফুল পার্ট অফ দিস চ্যাপ্টার, অ্যান্ড লাস্ট অফ অল গ্যালিলিওর লজ অফ ফলিং বডিজ। সো ফলিং বডিজের যে ম্যাথগুলো আছে এই চ্যাপ্টারে, অ্যান্ড ইকুয়েশনস অফ মোশন দিয়ে যে ম্যাথগুলো করতে হয়, এভরি সিঙ্গেল টাইপস অফ ম্যাথ যেটা তোমাদের টেস্ট পেপারে আছে বা বিভিন্ন ধরনের টেস্ট এক্সামিনেশন আসে বা ক্যাডেট কলেজে আসে, তখন আমাদের বুঝে করতে হবে। সো একটু মনে রাখতে হবে যে এই জিনিসগুলোর ব্যাখ্যাটা বোঝা এবং ম্যাথ ইমপ্লিমেন্টেশন করার ক্ষেত্রে দুই ধরনের স্কিল লাগবে। যেমন দেখো, এই যে ফার্স্টের দিকে আমরা যে পড়ছি রেস্ট অ্যান্ড মোশন অ্যান্ড দেন টাইপস অফ মোশন, আমরা যদি একটু ডিফাইন করার চেষ্টা করি যে ইন ফিজিক্স হোয়াট ইজ দ্য ডেফিনেশন অফ রেস্ট। আমি যদি বলি যে এই দুইটা পয়েন্ট আফটার দ্য টাইম অফ ইন্টারভাল তারা কেউ তাদের পজিশন চেঞ্জ করে নাই, দেন উই ক্যান সে যে এরা হচ্ছে ইন রেস্ট ফেজ। আমি শব্দটাকে বলতে পারি ইন রেস্ট ফেজ। কিন্তু যদি এমন হইতো যে এই দুইটা পয়েন্ট যেখানে ছিল বা যেটা বস্তু দুইটা এখানে ছিল, আফটার সাম টাইম তাদের কোনো একজনের জায়গা পরিবর্তন হয়েছে, অবস্থানের পরিবর্তন হয়েছে, পজিশন চেঞ্জ হয়েছে। সো ইন দ্যাট কেস ইফ ইউ সে দ্যাট পজিশন হ্যাজ চেঞ্জড আফটার সাম টাইম, দেন ইট ইজ মোশন। বাট অ্যাকচুয়ালি ফিজিক্সে এই পজিশন শব্দটাকে একটু ডিফাইন করতে হবে। এই কারণে আমরা যখন রেস্ট বা মোশন ডিফাইন করি তখন আমাদের একটা স্পেসিফিক একটা স্ট্যান্ডার্ড রেফারেন্স পয়েন্ট ও রেফারেন্স স্ট্রাকচার লাগবে, যেই জিনিসটার উপর বেস করে বা যেই পয়েন্টটার উপর বেস করে আমি পরবর্তীতে একটা জিনিস রেস্ট আছে না মোশনে আসে সেটা বলবো। সাপোজ আমি যদি চিন্তা করি যে এই পয়েন্টটা হচ্ছে রেফারেন্স পয়েন্ট, দিস ইজ ভেরি ইম্পর্ট্যান্ট, এই পয়েন্টটা হচ্ছে রেফারেন্স পয়েন্ট, দেন একটু চিন্তা করো যে এই রেফারেন্স পয়েন্টকে যদি আমি চিন্তা করি অ্যাট দ্য সেম টাইম যখন টাইম চেঞ্জ হয়, এই পয়েন্টের যদি তার পজিশন চেঞ্জ না হয়, দেন আমরা বলতে পারি যে দিস ইজ ইন এ রেস্ট ফেজ। বাট যদি পজিশন চেঞ্জ হয় তখন আমি বলবো এটা মোশন। যখন আমরা রেস্ট অ্যান্ড মোশনের কথা বলবো তখন আমাদের আরেকটা টার্ম মাথায় রাখতে হবে, অ্যাবসলিউট মোশন অ্যান্ড অ্যাবসলিউট রেস্ট। হোয়াট অ্যাবাউট দ্যাট? তুমি যখন একটা শব্দ উচ্চারণ করবা, দ্যাট অ্যাবসলিউট মোশন, দ্যাট মিনস যেই মোশনটা অলওয়েজ থাকবে। যেমন একটা অবজেক্টকে আমি বলতে চাই যেটা অলওয়েজ এটার মোশন ফেজে আছে, এটা বলা যাবে না। কেন? আবার যদি বলা যায় যে কোনো একটা বস্তু অলওয়েজ রেস্ট ফেজে আসে, তাও সেটা বলা যাবে না। কেন? থিঙ্ক অ্যাবাউট দ্যাট, এই আমরা যে ঘরটাতে থাকি, আমরা যে হোমে বিলং করি, এই হোমের ম্যাটেরিয়ালগুলো বা এই হোমের ফার্নিচারগুলো বা আমার ম্যাটেরিয়ালগুলো বা আমার ল্যাপটপটা যখন আমি বসে কাজ করি, ইট সিমস লাইক দ্যাট উই চুজ, আফটার সাম টাইম আমাদের পজিশন কিন্তু চেঞ্জ হচ্ছে না। মানুষ যখন ল্যাপটপে কাজ করে তখন 1 ঘন্টা 2 ঘন্টা ধরে কাজ করতেছে, তখন আমি বলতে পারি যে ইফ আই এম দ্য রেফারেন্স স্ট্রাকচার, দেন দ্য ল্যাপটপ ইজ ইন দ্য রেস্ট ফেজ, বিকজ After elapsed time, the position of the laptop were not changed. But you think যে আমরা কোথায় বিলং করতেছি? আর্থে. So earth is continuously revolving surrounding the sun. তো এই যে কন্টিনিউয়াস মুভ করতেছে, তার মানে আর্থের মধ্যে যা কিছু আছে everything is moving when the reference point is sun. So in earth, if you and your house is in rest phase, if you two are standing together without time and কোনো ধরনের যদি চেঞ্জ না হয়, then we can say that if your house is a reference structure, then you are in a rest phase. But you two belong in earth. যে আর্থটা পুরো সোলার সিস্টেমের মধ্যে সানকে ঘিরে এটা সারাউন্ডিং পজিশনে আছে. সো এভরি মোমেন্ট আর্থ কিন্তু রিভলভিং, and that is why every single thing which is in the earth is in motion phase. সো আমরা কিসের রেফারেন্সে বা কিসের বেসমেন্টে কোনো একটা কিছুকে বলবো যে ইজ ইট motion or is it rest, depending on the reference point. So এটা আমাদের মাথায় থাকতে হবে যে what is the definition of rest based on the reference point. After some time, if the position of something doesn't change, then we can say this is rest phase. But in case of motion, if it is changed, but we must consider a reference point. Okay, so এই রেস্ট এন্ড মোশনের ক্ষেত্রে তোমরা যখন পেজটুকু পড়বা তখন তোমাদের মাথায় এই জিনিসটা থাকতে হবে দ্যাট রেফারেন্স পয়েন্ট ইজ ইম্পর্ট্যান্ট. আমি কাকে রেফারেন্স পয়েন্ট চিন্তা করব? ওকে, লাইক এই এক্সাম্পলটা তোমাদের কাছে খুবই পরিচিত হইতে পারে. দ্যার একটা মুভিং ট্রেন আছে, এই মুভিং ট্রেনের মধ্যে একটা জায়গায় দুইটা ফ্রেন্ড বসে আছে ফেস টু ফেস, and they are talking with each other, but train is moving and they are inside the train, and what is happening if somebody is seeing that person from outside? So trainer বাইরে যে আছে standing position, he is saying that the train is moving in a direction. The persons who are sitting inside of the train, they are talking each other and they are actually in a rest phase, because if the person is a reference point, then this person is in rest phase, and if this person is a reference point, then he is in rest phase. So both of them are in rest, considering themselves as a reference point. But the outside of the body, যে বাইরে আছে তার রেফারেন্স পয়েন্ট যদি চিন্তা করি, তাহলে ট্রেন সহ এন্টায়ার এভরিবডি ইজ মুভিং. সো হু ইজ ইন রেস্ট ফেজ, হু ইজ ইন মোশন, or what is in motion, which object in motion depends on the reference structure. Okay, now think about some types of motion which is important. If we think about number one, then we can say that this is linear motion. What is linear motion? Very simple, very simple. If something is traveling through a straight line, anything, if you're kicking a football on a field and this football is moving in a straight way, light moves in a straight way. So if anything moves in a straight way, keeping a straight line, then this is called linear motion, which is very easy. So linear motion is a motion keeping a straight line ahead. Okay, now second thing is circular motion. So of course this is also common in our daily life, and you also know the definition is that if something or any object is traveling at a distance, that the distance is always same. The distance is always same. If you think the point and the structure of this circular shape, you can see that the circular motion is that motion that a object or any particle is moving based on a specific point, keeping the same distance, then this is called circular motion, which is also very easy for you. Of course, I think you can actually imagine what is the definition of circular motion. The important thing is that remembering the definition before, we must consider the concept. Is it clear? So linear motion is keeping the straight line, circular motion is like that. Now second circular motion, we must think another type of motion, which is actually translational motion. This is important. Translational motion. What does it mean actually? Translational motion means translational, that means that every particle, if a body or if any object is moving in such a way that every particle of that object is moving in the same direction, in the same time, in the same way. That means you can say that translational motion, it has three things that we must consider: that same distance, this is very important, same time, in a same time actually, and in a same direction, So three things is important. Translational movement is that if some object is moving in a way that every particle of that object is moving in the same distance, in the same time, at the same direction, then that motion is called translational motion. If you understand that, then the fourth thing is that, this is very important, periodic motion. Periodic motion. What does it mean actually? Periodic motion is another special type of motion where you'll find that means that something or an object is moving in such a way that it is actually passing every point at the same time interval, at the same direction, at the same manner. And here are three also important things to remember. That something, suppose think about the motion of a fan, or even your hand clock, this ticking clock is inside going on. That motion is called the periodic motion, which is going on and going on. Periodic means time interval. So when we'll decide or define the periodic motion, we say that number one, that same direction. What is the meaning of that? Think about that. This is a moving particle or something moving motion. Here you see that from that point it is coming in this direction, but in this point it is moving on that direction. But if I say that it's moving a minute, then you say that from this point to this point it requires 15 seconds. So each and every 1 minute time of interval, it will be passing that point in the same direction, same time interval, okay, and same manner. So there are three important things to remember when we will define periodic motion. The periodic motion is what? If a body or if a particle or if anything is moving in such a way that it is actually passing a specific point of time in same direction after same time interval at a same manner, then we call it periodic motion. And of course circular motion is one type of periodic motion. And when you understand the periodic motion, we must go into simple harmonic motion or oscillation. So I hope this is important. And now number 5, this is simple harmonic motion. So what is the meaning of that? Simple harmonic motion. This is one type of spatial periodic motion, but it has a little bit differences. Think about a simple pendulum, which is very common also. I hope you know it, that if you just make some sort of efforts, then it will be swinging on from this side to this side. And what is happening? Interesting thing is that it is happening from this direction to this direction. Let's say this is 1 second, and after some time, a little bit break, it will coming back again, and the time requirement is 1 second. So what is the nature of that motion? That every time when it is in a middle phase, after some time interval, it's coming from that directions, and with the same interval, it's coming from the opposite directions. If it's so, this is also periodic motion, but this is not like circular motion, or it's not like spring motion. It's about something that, you see, think about spring. So if you see that this is the spring and it's moving from this direction to this direction, like the vibration, this is also simple harmonic motion or oscillation. Because when you see closely that spring, any point, it's coming upwards and downwards, coming upwards and downwards after some time. So if you divide the time into two parts, then half of the time it goes upwards, and after the break and after that time interval, it's coming the second part in an opposite direction. So that is why simple harmonic motion is one type of specialized periodic motion. So periodic motion is that which has same direction, but there is a time interval on it, but in the same manner. And in case of translational motion, it has same direction, same time, and same distance. So in case of translational motion, an object is moving when all the particles of that object is moving in a same direction, same distance at the same time. This is translational. But in that case, periodic means going on and going on. Okay, so I hope it is clear when you will study about this motion, the definition of motion, that linear, circular, translational, periodic, and simple. And this is actually, I'm following the books, and there are a lot of other different type of motions, but I'm following the syllabus, and that is why I'm just sticking up with the pages. Now you think the next part. When you understand the type of motions, you understand the rest and motion, the definition of it, and of course, if in your exam, think about it, that in a creative questions is written, what is the definition of simple harmonic motion? Write it down. What is the definition of periodic motion? Write it down. Remember the point. Okay? Now I'm removing that part. এবার আমরা যদি একটু চিন্তা করি that what about the scalar and vector quantities? What about the scalar and vector quantities? In that case, I hope two important things we must remember, that is magnitude. That is magnitude. So, and second is direction. I hope you all know by the meantime that what is scalar quantities. Can you remember that what we studied in the previous chapter when we studied physical quantities and measurement? We studied fundamental quantities and derived quantities. What about fundamental? It means which is very independent, like we got 7 fundamental quantities. Right now, those quantities can be expressed by only magnitude, that is called scalar, and those quantities can be expressed by the both direction and magnitude. These are called vector quantities, which is very simple to understand. So I mean, the temperature of my body is like 37 degrees Celsius or 98.4 degree Fahrenheit. So this is the temperature. So the quantity of the temperature is expressed by the magnitude, the value. I mean, there is no direction is required here. So the time right now is 10:45 p.m. or 11:21 p.m., which is simply scalar quantities. No direction is required, either it is north or west or east, nothing required. So no direction is required, only magnitude is okay to express that quantities. This is called scalar. So we know about the scalar quantities like this: distance, scalar; speed, scalar. Like in case of time, I mean, well, let's think about the seconds, hour, this is scalar. So what are the scalar quantities? Which is only expressed by magnitude. So in some cases, we must think about it that there are some differences between scalar and vector quantity. And what are the differences? When you'll think about scalar quantity and vector quantity, now you think what are the differences between these two types of quantities? Number one, well, only magnitude. Okay, it can be expressed by only magnitude. Number one, that is both magnitude and direction is required. Okay, very simply. Number two, we can say that the addition, subtraction and multiplication of the quantities can be done by simple arithmetic way. Okay, like we can say that 5 seconds and 10 seconds, this is 15 seconds. Okay, but in case of vector, if you say that 5 Newton plus 7 Newton is not always 12 Newton, because it has a direction. So we can say that addition, subtraction, multiplication of these quantities can be done by simple arithmetic way or process. Simple arithmetic process, but here it is not possible to do it, I mean, within the simple arithmetic way. Geometric process is required. Okay, very simple. And you can give some examples over here. The number three, some examples you can provide. So if there is any sort of like differences is in your exam paper, you see that what are the differences between scalar and vector quantities, give it, but having the good understanding why this geometric process is required. Now you see simply one thing, that why simple arithmetic is not okay. Think about that. The 5 Newton force is applied in this point from this direction, and again 7 Newton force is also applied in this direction. Now we can say that both force is working and is giving in the same direction. Then we can say that 5 Newton and 7 Newton is 12 Newton. Okay, but if the angle of that force application is 180 degree, what will happen then? If in this direction 7 Newton force is applying and in these directions 5 Newton force is applying, and if I say that value, the angle in between is 180 degree, now you must think about it. It's not 12 Newton in together. It is actually 7 Newton minus 5 Newton, 2 Newton. And also if 7 Newton is applied here and 5 Newton is applied here, and there is an intermediate angle in between these two forces, then we must consider this angle also in case of vector quantities. And that is why we cannot add, we cannot subtract, we cannot multiply these vector quantities by arithmetic values. We must need a geometric process, and that is the speciality of vector quantities, as it has the direction. Okay, so it is very simple about it. Now you think again about the next topic. এর পরের টপিকগুলো আমাদের মনে রাখতে হবে যে এগুলা কতটা সুন্দর, বিউটিফুল এবং কতটা মজার হতে পারে। Think about the scalar and vector quantities এর পরে যখন আমরা displacement and distance নিয়ে কথা বলবো, এটা খুবই মজার। যখন তুমি distance নিয়ে কথা বলবা, it means this is scalar, it doesn't have any direction, but when I think about displacement, then we must think in a different way. Displacement. Now you think this is scalar quantity. scalar quantity and this is vector quantity. Okay, the distance is actually expressed by d. Okay, d is very simple, d, but the displacement is expressed by s. The unit is expression. Okay, this is the expression, so we express distance by d. Number 3, in case of unit we express it by meter, and also in this case the unit is also meter. If you think about the dimension is length, as this is only distance, its length, so we can say the dimension is L, and also here the dimension is L. Now think about the concept. If you see that an object is moving 5 meter in north, and then if it is north, this is south, then this is east. So what is the distance? If I say that this is 7 meter and 5 meter, if it traverses in such a way from A to B to C in this angle, keeping that is 90 degree in between, then this distance is actually 7 meter plus 5 meter is 12 meter. Very simple. But if in case of displacement, then we must say the definition is that displacement is the shortest distance between the objects, between the two objects. Like how it happens. Now you think that it comes from 7 meter from north to 5 meter to south, then this is 7 meter. Okay, this is, think about 90 degree, and this is 5 meter. What is the displacement? Now we have to draw a hypotenuse over this triangle. And now if this is A, B and C, we must know this AC is the displacement of that particle, and that is root over 5 square plus 7 square. The value here it comes, that is the meter, which is the value of displacement. Very simple. Okay, if a body is traveling like this from here to here to here to here, like 100 kilometer, যে A থেকে একটা particle or a cyclist or anybody is running for 100 kilometer from this point to this point, that is the distance. So distance traveled by the person or anything from that point to point is 100 kilometer. If I say, then the distance is 100 kilometer, which is okay, but the displacement is, we have to draw an intermediate line in between these two dots, and this might be like, okay, it might be like 5 kilometer. Then the displacement is 5 kilometer, but the distance is suppose 100 kilometer. So we can say the shortest distance is the displacement. Okay, so I hope in case of distance and displacement you would understand either that this is the scalar quantity and this one the vector quantity. Okay, I hope you can do it, and you can think about the process that how you can measure it, or you can say that something is moving in a circular way from this side and it is moving 2.5 round from its starting point. Think about it, that this is A, this is B, and this is C and D. Suppose it has 4 points in this circular movement. So somebody is running through a circular point and gives 2.5 round, and then after it comes in this way. Okay, so this is C, and we can say the radius, if the radius is 5 meter, then the distance covered by the person is what? Is just 2.5 times. So 2.5 times 2 pi r. This is the distance traveled by the person, because the rounding. So 2 pi r and 2.5 times. But what is the displacement? Which is simply from A to C. That is only 10 meter. As the 5 meter is the radius, so the 10 meter is the displacement, which is equal to the diameter. So very simply, whenever we think about any sort of distance or displacement, please think about this one. Okay? I hope you understand. Now you think that okay, so I hope you can understand the process also, and think about the velocity and the speed. When you think about the velocity and speed, this is the same way we are thinking about it. What is that? Suppose this is speed in that part, this is speed, and this is velocity. Okay, now think about it. The line is getting so much oblique here. Actually it should be in this way. Okay, well, again, so স্পিডের ক্ষেত্রে আমরা কি করি? স্পিড হচ্ছে, আমি যখন স্পিডের কথা বলবো তখন আমার ডেফিনেশনটা কি হবে? আমি যখন স্পিডের কথা বলবো আমার ডেফিনেশন হবে distance over elapsed time, and in that case velocity হবে displacement over time. So what is the difference? The difference is huge here with the elapsed time. So whenever we say that v equal d by t, we must think this is the speed and scalar. The unit meter per second, the dimension L t inverse 1, which is same. So in that case, when we count about v equals s by t, this s is the displacement, which is vector. So now you think the speed and velocity, there is a differences. Like what? Now you think that a person is coming from 7 meter to 5 meter, from that direction keeping 90-degree angle from both side, and he took like 2 minutes. Okay, so 2 minutes, that is 120 seconds, and he traveled 10 or 12 kilometer, or like, okay, 12,000 meter. Now you think that person travels 120, that is 100 meter per second. This is the speed. Okay, this is the speed. So the total distance covered by the person is 7 kilometer and 5 kilometer. Just think about it. Okay, think about it. And if I want to count the displacement, we must think this is the line, and the time required is 120 seconds, which is okay. But now if we count the velocity, then we must count the differences from A to C, and that is 7 kilometer, that is 7,000 meter. So it would be like 7 kilometer plus 5 kilometers, so 7,000 square plus 5,000 square, that is the root divided by 120 seconds. So now we see that the velocity and the displacement, velocity and speed are not same. When we'll think about this value, the distance is covered by them, then the displacement or the distance are not same. So speed and velocity of a person or anything could not be same because of the variation. So I hope you understand the process in case of speed and velocity. Now we think about acceleration and retardation. What is the meaning of that? In case of acceleration, we say that the change of velocity over the time. And to understand that, we need to think that something is moving from this side to this side. Okay, So when it started its journey, that is the initial velocity. Now you think about u, which is initial velocity, and after some time or elapsed time, it gained its final velocity. Okay, so there is a time required, that is the elapsed time. So the change of velocity is that it gains its velocity v and minus u over the time, which is the acceleration. It might be positive or it might be negative. How? If the value of v is greater than u, we say that it gains some velocity. But if u is greater than v, we say that it loses its velocity, and hence the negative acceleration will happen. And this negative acceleration is called retardation. So what is retardation? If the velocity, negative acceleration is called retardation in one sentence. So in case of retardation, we'll find the value is coming minus. In case of acceleration, it means the changes of velocity, positive changes. We must not say that positive changes, we say that changes of velocity over elapsed time is called acceleration. It might be positive, it might be negative. Okay, so very simple. Now the beautiful part of this chapter comes like equation of the motion. Now the beautiful part arrives. People, you just think যে এতক্ষণ আমরা যা পড়লাম, এতক্ষণ আমরা যা চিন্তা করলাম, আই এম কোয়াইট শিওর যে তোমরা এগুলো হয়তো জানো, বিকজ একবার রিডিং পড়লেই বইটার মধ্যে আই থিঙ্ক তোমাদের ভিতর থেকে সেই প্রেরণার জায়গাটা, সেই আন্ডারস্ট্যান্ডিংয়ের জায়গাটা আসবে। নাও ইউ থিঙ্ক দ্যাট what I'm writing here. Number one is like that. Okay, so we studied what? Velocity is the displacement over time. Okay, so now we can say, okay, that s is equal vt. So we got the first equations from the definition of velocity. What we know, that velocity is the displacement over the elapsed time, and in case of equation of motion, we must think one thing, that is so that. Please just remember this thing, so that. So we will have to think about these 5 quantities, that is s is the displacement, u is the initial velocity, v is the final velocity, a is the acceleration, and t is the time or elapsed time that is required. So we can say that s is the displacement covered by the particle or the object or the person, and u is the initial velocity of the person or the object or anything, and t is the elapsed time. Now you think how to use that. So from the definition of velocity, we got an equation, and we take this as number 1. Now you think about the second part, that is the definition of acceleration. What we studied, that the change of velocity over time is acceleration. Now we can say that v minus u is equal a times t. Okay, so if it is true, then v equals u plus at. We got the second equation. So we can write it in a red color to make it a different. Well, what is going on here? You say that the whole time the velocity will be remaining same, which is not possible in all cases. So as there is some changes of velocity, we cannot count this velocity for granted. So we need a mean value. So what is the mean value of that v? So in that case, we need s equal vt, and this v is the mean velocity. So by definition we know that mean velocity is the initial velocity by final velocity divided by 2. So if we can use this one, here, now you think S equal V, so we can say U plus V by 2 into T from this equation. Now you think about it, S equal U plus V by 2 into T. From these equations we got what? We got V equal U plus AT. So this is the equations comes from V, and this is 2 times T. And from that we are getting another equations, which is that S equals to 2U times T plus A T square by 2. And now if I just get a divide, we find it that S equal to 2UT divided by 2 plus AT square divided by 2. And now we are getting another equation, that is S equal UT plus half AT square. And this is another equation of motion, the beauty. Okay, so I hope you understand that part. And now let's consider the other part, that we simply say, well, this one, well, we are deducing it from the equations that V equals U plus AT. So now if I square the both part, what will happen? Then it would be V square. Well, now we can consider that A plus B whole square, which is U square plus 2U A T plus A square T square. So we are just squaring it, and then okay, then what we can say that, okay, V square equal U square. If I just get 2A as common factor, then we say UT plus half A T square. Very simple. And now we are getting another equation, as because UT plus half AT square is equal S, we just deduce it just earlier. So this is V square equal U square plus 2A. S is another equations of motion. So we can deduce it from the very beginning, and I hope you see it, you understand it, and you can apply it on the mathematics. That is the most important part on your exam paper, because how much you know the physics that can be proved by your exam result. And we all want a good result, because we have to answer all these questions perfectly, accurately. And to get those things accurately, we must practice in our right now this time properly, beautifully. Okay, this is very easy, but the thing is that how to use the part in which way. We're getting from the first one that where V, this capital V means mean velocity. Why? Because this V cannot expressed when there is a continuous changes of velocity. If and after elapsed time, that is important, elapsed time, if the accurate velocity or the final velocity has some sort of changes, then we say this is V and U is the initial velocity. So now I hope you can understand how to deduce these equations from the definition. Very simply we use the definition of displacement. Very simply we use the definition of acceleration, the changes of velocity over the time. Okay. In some cases, when you will use the unit of this velocity, you must consider one thing, that either it is given in second, meter per second. If it is not in meter per second, we cannot use in a mathematical way. What is the meaning of that? Something like that, that it's given that 60 kilometer per hour somebody or something is moving from rest, when it is written that something is starting from rest, or after braking or pushing the brake, it's getting on the rest, then we must see either initial velocity or the final velocity is 0. So if it is said that something started from rest, we say that the initial velocity is 0 and the final velocity is km/h, which must, I have to convert it into meter per second. How? We must know that 60 kilometer is that, so this is 1 hour, and that is the velocity of 60 km/h. So now we see that 60 times kilometer, which is 1000 meter, divided by 1 hour, which is 3600 seconds, which is actually very simple, that 1 hour, that is 60 minutes 60 seconds. So now we are getting it in seconds. So as we have 2 zeros from this side and 6 tens this side, so we can say that is 100 divided by 6, is it? So very simply we can say that 60 divided by, which is 16.67 meter per second. So whenever in your question paper km/h is given, we must convert it into meter per second by doing a very simple trick. It's just dividing by 3.6. So whenever you see that something km/h is given, just divide it by 3.6. Why? Because we are dividing it 1000 divided by 3600. So if we divide by 3.6, which is equal to this one, so that is 16.67 meter per second. Okay, I hope this is okay, and you people are talented. If you just read your books, you'll definitely get the idea. I'm just giving the lectures. If you want, okay. And then in some cases what will happen, that mile/h can be given, like something is moving in mile/h. Suppose 60 mile/h is given, but we need to convert it into meter per second. So what to do? We need to convert it first in kilometer, and we must know that 1 mile is 1.6 kilometer. So if it is 60 mile/h given, so we can say that 60 into 1.6, that is converted into kilometer, and then now multiply by 1000, which is meter, and then this is 3600 per second. Now the mile/h becomes meter per second. So that is the unit we are looking for. So 2020. So we have what? We have 10, we have 6, so we have 16 times what? 160 over 6. So what is the value? I think I need a calculator. 160 divided by 6, which is, okay, 26.67. So we can say 26.67 meter per second. We have to use this value whenever we'll think about this 60 mile/h. So whenever in your question mile/h magnitude is given, we have to convert it into meter per second, or km/h is given, we have to convert it into meter per second. Okay, I hope it's okay. Now you think the next part. The next part is what we need to use. We just learned or deduce some equations that in case of S equal Vt, we'll use it. Secondly, we'll use it V equal U plus At. Thirdly, we used S equal Ut plus half At square, and fourth, V square equal U square plus 2As. So this is the equation of motion. But in case of understanding the falling bodies, Galileo Galilei, which is sometimes says the father of modern science, started these things in Italy, in the Pisa city, that some experiments done by him and given a very important laws which is known as laws of falling bodies. What are those? Number one, in case of laws of falling bodies, number one, that is, there is a condition. What is the condition? That something is falling to the ground from the same height, okay, without any sort of like obligations, without any sort of forces applied or something like that, freely falling bodies from the same height without any sort of interruptions. If it's so, that if you just think about the laws of falling bodies, what is actually written on your question paper, that is number one, all bodies falling from rest from the same height without any resistance. So there are three conditions. All the bodies should be in rest, number one condition, from the same height, second condition, and without any resistance, without any resistance, which is the third condition. If it's so, then from the laws of falling bodies, Galileo says that all the particles, all the bodies will traverse the same distance at the same time. What does it mean? That if the mass of this object is 5 gram, this one is 5 kilogram, and this one is 5,000 kilogram. If this three different masses object is falling freely from the same height, from the rest, and without any resistance, that all of them will traverse the same distance at the same time. It means what? If it comes to the ground within 2 seconds, then it will come to this ground also in 2 seconds, and this one also in 2 seconds. So every falling bodies, if the three conditions are said, that from rest, from same height, without resistance, it will traverse the same distance at the same time. First law. The second law is that the velocity attained by that falling bodies is directly proportional to the time required to gain that velocity. That means that v is proportional to t. That means that all these falling bodies is freely falling without any resistance from the same height, from the rest, and the gained velocity depends on the time required. So v is proportional to t. And then the third law comes, that the velocity, it's not about velocity, the third law is about height. So if the particles is falling from this height, the height or the distance traversed by that particles is directly proportional to the square of the time. It's very important, square of the time. So v is proportional to t when the attained or the gained velocity is proportional to time. And in case of height, h is proportional to t square. And that is why in case of falling bodies, the acceleration which is working here is actually about due to gravity. And that is why in case of falling bodies, we wrote these equations as v equal u plus gt. In case of s, it would be h. So second law, or the second principle, we can say that h equal ut plus half. There is no acceleration in that case, so this is gt square. And thirdly, we can say that v square equal u square plus 2gh. So these equations will turn into this one. These equations will turn into this one. So the beautiful part of this chapter that there are a lot of principles we have to use in different way, and তোমরা যারা চেষ্টা করছো, পড়ছো, স্টাডি করছো ইংলিশ বইটা বাট নেটিভ বাংলা, তাদের জন্য বলছি দ্যাট উইল ডেফিনেটলি স্টাডি অন দিস থিংস। আমার যেটা মনে হয় যে তোমাদের ইংরেজি শুনতে হবে, ইংরেজি পড়তে হবে, ইংরেজি ভাবতে হবে, ইংরেজি লিখতে হবে, বাট টু আন্ডারস্ট্যান্ড থিংস ক্লিয়ারলি ইফ ইউ নিড Bangla explanations in our mother tongue, then I'm using it. So I feel good to explain it in English, but sometimes I feel also good to explain it in Bangla when I feel it. Depends on my mental status. So of course, those you are watching right now this tutorial, this is the full lectures on a single chapter. So I would try my level best to upload all these chapters totally in a single video. If you want to look over all these things and to understand things clearly, and I will follow the topic based on the books and based on the syllabus. And students basically from Cadet College, take my love, you people are having a very good life with disciplines, depends on your point of view, how you think about your life, how you manage your life. But whenever we will study, we want one thing, that we want to study with joyful and peaceful mind, that we are gaining some knowledge, and we are studying physics, so there is a mathematics, so we have to answer those mathematics, we have to understand the questions, we have to think about the equations, how we can go there, and how we find our objective using the data available in the questions. So whenever some sort of questions in your question paper, write it down and think about it, what are the data is given, and whenever I will explain it in mathematics, I will draw a figure and find out the data, what is there, and to use these equations available from the data. So today this is my lecture about motion, and the next lecture I'll be focusing on force, the third chapter, and which is another beautiful chapter of physics. So stay well, take care, be healthy, and stay cool. Take care, bye.